Welcome back everybody to linuxacademy.com. My name is Terry, and in today's video we're going to continue our exploration of Nginx, the web server. So in our previous videos we've spent a lot of time talking about our vhost configuration, and now what we're going to do is take a step back and begin to, as we build on the complexity of our web instance implementation, let's revisit the nginx.conf file and look at some ways that we can optimize Nginx to work on our particular system. So we're going to take a look at things like how much memory we have available, how many CPUs we have available, and how that can affect the amount of processes, threads, and other limits that we can set within our Nginx configuration to optimize its performance on our system. So let's go ahead and go to our etc Nginx directory, and as we've looked at before, our nginx.conf file is located in the root of this directory, the etc Nginx directory. So if we edit this file, we'll see a large number of options that are already defined in this file, and we're going to take a look at some of them. So let's take a look at first what we call worker processes and connections. So these two variables are really kind of the backbone of Nginx. So we'll start with worker processes. It's responsible for letting the virtual server know, or your physical server, know how many workers to spawn once it's become bound to the proper IP address and ports. In our case, we just have it bound to our local host IP as well as the port 80, but it can be, if we have multiple Ethernet addresses on our system, virtual or otherwise, bridged adapters, etc., we can of course bind Nginx to any of those IPs, and we can bind it to any port. 80, 443 are the two most common ones, but of course it can be bound to any port that we wish. It's pretty common to run one worker process per core. Anything above one worker process per core won't really hurt our system, but it may leave some idle connections laying about that we can't get to. In other words, we may be allocating more worker processes than we have CPU horsepower to deal with. So one of the things that we need to do is we'll go ahead and drop out of our Nginx configuration file, and let's take a look at how many processors we have available on our system. And the easiest way to do that, if you've been around Linux Academy long enough, you know that all of our system level information on the hardware that's on our system can be gathered by looking in various places in the proc directory. So if we take a look at proc CPU info, we should be able to list all of the processors that we have on our system, and this particular one in terms of processor will tell us which processor we're dealing with. And in our case, we only have one entry, and it's going to tell us that we then have one core on the system. Now we could have, if we had a multiple core system, we could have just done a grep on the word processor, and then we could have done a WC minus L, which would tell us that we have one. So we have one core available on our system, and that's because we have a relatively small virtual machine that we're running. So now that we know we have one core, we're just going to leave that value at 1, and we're going to talk about the second variable. The worker connections variable tells our worker processes how many concurrent connections that Nginx can serve. In other words, how many people or end users can be simultaneously served as a web connection on Nginx. By default, the worker connections defaults to 768. However, keep in mind that generally browsers open 2 or 3 connections, usually 2, but some browsers do open 3 connections to every server, so it's best to half that number of 768. So we're going to adjust our worker connections to the full potential of our system, and we can count, or we can check our core limitations by issuing the ulimit command. So if we go ahead and clear this up, and if we do a ulimit-n, then it will tell us that it's 1024. So it's a good starting number. So let's go ahead and update our configuration. So let's go ahead and do a VI on our Nginx configuration file, and we're going to find worker processes. And if it doesn't exist, we're going to add it. because worker processes by default, if it's not defined, will default to 1. And in this case, it's already defined as 1. And our worker connections is 1024 by default. So we're actually already configured for this Nginx default installation pretty well for our existing system. The only adjustments we would have made is if we'd had more than one core available to our system, we would have adjusted the worker processes, and then the number of worker connections would have reflected 1024 times that. So since we've already got that in place, we can go ahead and leave that in place. And there are other things that can affect it, such as the keep alive timeout directive, but we'll talk about that in a later video. The next thing we're going to talk about is buffers. So one of the important things to remember about buffer sizes is if they're too low, then Nginx will have to write out temporary files, which could cause read-write constantly on your system. And one of the biggest detractors from a lot of reads and writes is it can significantly add to load on the system. And the more load that's on a system, the more I/O wait that happens, the longer it takes to respond to requests. So there are 3 buffer types that we're going to talk about. We're going to talk about client body buffer size, client header buffer size, and client max body size. So first, client body buffer size handles the client buffer side or anything that's posted, post actions sent to Nginx. They're typically form submissions, for example. Client header buffer size, however, although it's similar, it only handles client header size. So for all intents and purposes, 1024 is a decent size for that particular directive. Finally, client max body size is the maximum allowed size for a client request. So if the maximum size is exceeded, then Nginx will spit out a 413 error, or what's called a request entity too large. And then one more, there is a large client header buffer, which is the maximum number and size of the buffers for large client headers. So we're going to add a couple, or we're going to add all of these in what is typical for a Nginx configuration optimized to handle medium to high traffic loads. So if we start by looking for whether we have a client buffer size, let's do a client body buffer size and see if it's set anywhere. So it's not. So one of the places that we need to add this is we can add this in our Nginx configuration file. And we'll want to be careful because we want to place these variables, these settings in the correct place. You'll see that the worker connections is placed in the events directive, where we're going to place all of the client buffers is in the HTTP. And in our case, we're going to place it in HTTP because we've chose to define our vhosts outside of the Nginx configuration file. So we're actually just going to go back to the bottom of this, and right before the directive to include the configuration and vhost file, we're just going to insert our variables here. So if we want to start with the client body buffer size, again, we're going to put client body buffer and size, and we're going to set that for 10K. And remember that when we end a configuration directive inside of any of our files for Nginx, you always have to end it with a semicolon. So we've got client body buffer size. And the next variable we want to put in here is, as we talked about, the client header buffer size. And we talked about 1K being a good place to start for that. And the next one was the client max body size, and we're going to give that a fairly large value, but in terms of the memory that might be available for your system, and what you have available in terms of what you're serving, you may need to increase this a bit. If you see the error that we talked about earlier where the request entity is too large, then you'll need to increase this value. Right now we're just going to set it for 8 megabytes. It'll support up to the value of the maximum memory on your system. However, you have to build in some OS overhead. So if you had a 4 gigabyte system, you could technically set it up for 4 gigabytes. However, if you actually had a client max body size in there, or the maximum allowed size was actually 4 gigabytes, at a minimum, you would likely be paging out, and it wouldn't all be coming from memory, so the performance would be pretty poor. So the last one we're going to put is the large client header buffers, and we're going to indicate that we should have 2 at 1K. So now if we save our settings, we've made these changes, and you may have made changes to your worker connections or worker processes. We've made 2 sets of changes, and I recommend between optimization processes that you test your configuration to make sure we haven't made any typos or added invalid values. In our case, we're okay, so we're going to go ahead and continue. We'll go back into our Nginx configuration file, and the next thing we're going to talk about is timeouts. And timeouts are important because they can drastically improve the performance of our Nginx web server. We're going to talk about client body timeout and the header timeout. And what they are is they're directives that are responsible for the time that your server will wait for your client body or header to be sent after the request. So if neither one is sent, the server issues a 408 error or a request timeout. In conjunction with that, there's another directive, keep alive timeout, that assigns the timeout for keep alive connections with the client. Basically, that just means Nginx will close connections with the client after this period of time. And then the last timeout that we want to set is the send timeout. The send timeout is actually established not on the entire transfer of the connection that sent the entire transaction, but between 2 operations of reading. So if after this time the client will take nothing, then Nginx will shut down the connection. So we're going to add those, and again, those are going to be added in our case to the HTTP directive because that's exactly what they affect the most, and we don't have a server directive inside of this particular configuration file. So let's go ahead and add some space for it, and we'll add the variables that we talked about. So we're going to do the client body timeout, and in all honesty, you don't really want to wait more than this is in seconds. 12 seconds is generally what's considered the maximum amount of time that a web page should take to draw once it's been requested, either in body or header. I think that's a bit too long. And in the case of enterprise websites, it's generally considered that you don't want your website to take more than 3 to 5 seconds to load. However, you do have to configure your server for what's called worst case scenario. So if you expect your connections, your concurrency to be pretty close to max most of the time, you have to realize that your system on occasion is going to reach the maximum values that you've set. So you're going to configure your system for the worst case scenario. So again, that's basically what we're doing here, is we're configuring these timeouts so that they don't take any longer than the absolute maximum amount of time before we start returning errors. This can be monitored from a performance perspective. You can have monitors that say, hey, if I don't get a response back in more than 12 seconds, or I get the 408 error request timeout, then you can send a monitor so that your monitoring software can return that your website is overloaded. So once more, now that we've made these configuration changes, we'll go ahead and save our connections. And then finally, before we issue a restart, we're going to do an Nginx-T, and we'll see that the keep alive timeout directive has been duplicated. So we need to go back into our configuration, and we'll find the initial value and change it. And we have the keep alive timeout at 15. So we'll find where we have it defined already, and we have it keep alive timeout of 65, which is actually much too long. Our system should never take that long before killing off a connection from a client that's been idle. So we're going to change that to 15. And again, this is why we issue the Nginx-T rather than just issuing a restart, which could stop the web server and fail to load the configuration. In this case, we've now fixed the directive, and if we do a service nginx restart, it'll reload our web server. Now, these are just some of the major areas that we can do some optimization, and these focused completely on client and timeout optimization so that we had the best performance for the highest concurrency possible. This isn't an easily testable level of optimizations unless we throw significant load on it. So during our use cases, what we'll look at doing is look at how some of these settings can affect end user web server performance. But for optimizing our nginx.configuration file, that's all there is to it for now. My name is Terry for Linux Academy.